Aldol condensation reaction. This reaction is a named reaction in organic chemistry. In this reaction, two molecules of aldehyde or two molecules of ketones having the presence of alpha hydrogen atom in the presence of dilute alkali, that is your dilute sodium hydroxide or dilute barium hydroxide, undergo condensation process, and if it is an aldehyde it forms beta hydroxy aldehyde. If it is a case of ketone, it forms beta hydroxy ketones. Let's see an example. Here I am taking an aldehyde called ethanol. The formula of ethanol is CH3C double bond OH. So here we need two molecules of ethanol. Another one will be CH3C double bond OH. We can observe that this is an aldehyde group and this is considered to be the alpha carbon, and to the alpha carbon whatever the hydrogen atom are getting attached, they are considered to be alpha hydrogen atom. So means in this aldehyde there is a presence of alpha hydrogen atom. So it undergo process of condensation in the presence of dilute sodium hydroxide, and finally it forms a product. Here it will be CH3COH CH2, and H will be getting attached to the carbon to which OH is attached. Then finally COOH. Here we can observe that this is an aldehyde group, this is an alpha carbon, this is a beta carbon, and to the beta carbon hydroxy group is attached. So that is what beta hydroxy aldehyde is formed, and the name of this particular compound is 3-hydroxy butanol. When it is further heated, there will be a loss of water molecule, and finally it forms a specific compound called protonaldehyde, or you can say 2-butanol. CH3CH double bond CHC double bond OH. It is called 2-butanol, or by the common name it is called monoaldehyde. Let's see another example where I am taking propanol, which is an aldehyde. The formula of propanol will be CH3CH2C double bond OH. Another molecule of propanol is written as CH3CH2C double bond OH. In both the cases we can see this is alpha carbon, this one is also alpha carbon. So both are having the presence of alpha hydrogen atom. So it undergo condensation process in the presence of dilute sodium hydroxide, and finally it forms a product as beta hydroxy aldehyde. Here it will be 3-hydroxy 2-methyl pentenol. So it is CH3 CH2 C OH H CH CH3 C double bond OH. This is the aldehyde group. This one is alpha carbon, this is beta carbon. So at the beta carbon OH group is getting attached, so it's a beta hydroxy aldehyde, and its name will be 3-hydroxy 2-methyl pentenol. When it is further heated, there will be a loss of water molecule, and it forms a compound where you will observe there is a double bond comes out between two carbon atoms. It will be CH3, CH2, CH, double bond C, CH3, single bond C, double bond O, H. So a double bond comes out between two carbon atoms and its name is 2-methyl. 2-methyl pent-2-enol. Let's see another example in case of ketone. Here I am taking propanone. The formula of propanone is CH3, C, double bond O, CH3. So two molecules of propanone is taken, CH3, C, double bond O, CH3. In this case also we can observe if it is a functional group, then this is alpha carbon, and this alpha carbon is having the presence of alpha hydrogen atom. Similarly in the second case also. So for ketones also this reaction is applicable. Condensation process take place in the presence of dilute alkali. Here this time we are taking barium hydroxide, dilute barium hydroxide, and finally it forms beta hydroxy ketone. Here it will be CH3, C, OH, single bond CH3, CH2, C double O, CH3. It is called 4-hydroxy 4-methyl 2-pentanone. So you can observe that this is a functional group. It is at second 1, 2. So 2-pentanone 1, 2, 3, 4, 5. 5 carbon atoms in a long chain. 1, 2, 3, 4. At the fourth position hydroxy group is there. At the fourth position only methyl group is there. So 4-hydroxy, 4-hydroxy, 4-methyl 2-pentanone. Then if it is heated, there will be a loss of water molecule, and ene group, or you can say double bonds, comes between two carbon atoms, and the new product forms out as CH3, C, CH3, double bond, CH, single bond, double bond O, CH3. It is called 4-methyl pent 3N2-O, and it is commonly called methyl oxide. One important note point comes out in this condensation reaction, that your formaldehyde SCHO and your benzaldehyde, where a benzene ring attached to the CHO group, both does not show aldol condensation reaction, as we can see that in this no alpha carbon is there. If alpha carbon is not present, means alpha hydrogen atom is not present. Alpha hydrogen atom is not present. So we'll see that aldol condensation reaction is not applicable for formaldehyde and benzaldehyde. If we repeat the same reaction once more time, we will come across it how the two molecules of aldehyde undergo condensation reaction, because there is having the presence of alpha hydrogen atom in the presence of dilute alkali. It could be sodium hydroxide or it could be your barium hydroxide, and finally it should form a specific type of compound that is called beta hydroxy aldehyde. Similarly, in case of ketones also, two molecules of ketones undergo condensation reaction because they are having the presence of alpha hydrogen atom in the presence of dilute alkali, and finally they lead to the formation of beta hydroxy ketone. So this is what aldol condensation reaction. Thank you.